Okay, in this video we're going to actually work out how to find the constant of integration. So if the gradient of the tangent to a curve and the point on it are known, the equation of the curve can be found by integrating the gradient and substituting in the point. So we're going to jump to the example here and see how we get on with this. So this example says the gradient of a tangent to a curve is 3x squared plus 1 over x cubed minus 3, and also the curve passes through the point minus 1, 8. Find the equation of the curve. Okay, the gradient of the tangent to the curve is given by that function. So that tells you dy by dx is equal to 3x squared plus 1 over x cubed. Oh, sorry, that's a minus 3. Get rid of that, minus 3. So we have 3x squared plus 1 over x cubed minus 3 is your gradient of your function. It's not an index form, so just tidy up this middle term. The middle term is going to be x to the minus 3 and minus 3. So if that's your curve, that's your dy by dx. How you get from dy by dx, just remember you went from y to your dy by dx by differentiating. That means you're going to go the other way around by integrating. So if you differentiate to get from y to dy by dx, you're going to do the reverse. You're integrating to get from dy by dx to back to y. So that means y is equal to the integral of your dy by dx with respect to x. So in this case, y is going to be equal to the integral of 3x squared plus x to minus 3 integrated with respect to x. Wee bit of working out to do for this. So that's going to be 3x squared integrated would be 3x cubed divided by 3, so just x cubed. And that's going to be plus raise the power by 1, that would be minus 2, divided by minus 2, and then minus 3x, and then plus your constant of integration. Okay, I'll just write that up here. Bear with me, I'll just rub a few things out. Okay, so we'll write that again. Your y then is equal to x cubed, and then we had x to the minus 2 divided by minus 2. So that is going to be, we'll show all our steps here, that's going to be 1 over minus 2 upon 1 over x squared minus 3x plus c. So just to show us where this all comes from, that's going to be x cubed, and then that will be then multiplying on the top. 1 times the 1 is going to be 1 on the top line, and it's minus, remember, so minus 1 over, and then 2x squared goes on the bottom line. So that's what you've got. Okay, that's fairly tricky bit of work there. What we've now got, we've got our function of our curve, we've got everything on it worked out except for your c. So you need to find your c. So just say at the point minus 1, 8. That means x is equal to minus 1 when y is equal to 8. So instead of writing y, you're going to write 8. And everywhere you see x, you're going to replace it with a minus 1. So it's minus 1 cubed, then minus 1 over 2 upon minus 1 squared. That's a minus 1, believe it or not. And then minus 3 times minus 1 plus c. So that's going to be 8 is equal to minus 1 cubed will be minus 1. And that's now going to be minus a half, that will all work out to be. And then that will be plus 3 plus c. That's still a mess, so let's tidy it up. You're going to have plus 3 minus 1 is 2, minus another half is going to be 1.5. So 8 is equal to 1.5 plus c. So bring that 1.5 across. You'll have 8 minus 1.5 is equal to c. So your c is equal to 6.5. Your last line, or your answer, is going to be rewrite your equation of your y with your c in it. This is a big mistake people make. They just leave it as I have at the minute. But rewrite it all. It's going to be y is equal to x cubed minus 1 over 2x squared minus 3x, and then plus your 6.5 at the end. Okay, you're now ready to do exercise D from your CCA book, and that should be okay.